Hello students, we are continuing with chapter 13 on repeated games. Okay, let's go to table 13.8. Repeated games is where actions are taken and payoffs are received over and over again. So it's not like the prisoner's dilemma, which is terminal only once. You decide whether to confess or don't confess, and then you go to jail. But in business, you have repeated games. Every time you make a new decision about investment or about advertising, there will be opportunities for that from time to time, and the sense of in the long run, your competitors will learn to to know your behavior, whether you are a risk taker or not a risk taker, and then you will develop a reputation among your competitors about how you deal with the market, whether you are aggressive or passive in the market. So let's use this example here: pricing problem, firm 1 and firm 2. In a repeated game. Again, we start by checking dominant strategy. Firm 1, dominant strategy exists or not. 10 and 100, negative 50 and 50 doesn't seem to have a dominant strategy. Firm 2, same, 10 and 100, negative 50 and 50. So it also does not have a dominant strategy. Okay. But if, let's say, we take a scenario where both firms decide to charge high prices for their goods, and with high prices, then you end up with this equilibrium where both of them can get 50-50. This is the high price box. Okay. And if one firm decides to undercut the other, let's say in this case, firm 1 undercut, then firm 2, firm 1 undercut, that means firm 1 take a low price action, firm 2 will lose. So it's 100 and firm 2 will lose, you will get negative 50. Or alternatively, if firm 2 decides to undercut the price, then firm 2 will gain 100, but firm 1 will lose negative 50. So any deviation will cause the other firm to lose. Okay, but they also know that the other firm has a chance to retaliate in the next game. So therefore, they should be thinking very carefully whether they want to use this strategy of undercutting your competitor. Because it's not over. There is repeated. There's a chance for another game or another period. So in that case, a stable situation will be 50-50 here, simply because they are afraid of the tit for tat, retaliation. Similarly, if they choose to start at a low price, so they both get 10 and 10, okay, the company or the firm that decides to charge a high price, that means deviate from this equilibrium, if they deviate from equilibrium, then that company with a high price, say firm 2 choose to go high price, then it will lose negative 50, but the other company will gain and earn a profit of positive 100. Similarly, if you start from this low price and then suddenly firm 1 wants to charge high price, so firm 1 will lose negative 50, firm 2 will gain more and gets 100 million profit. Okay, so either low price or high price, simply because they know that it's better to maintain a certain equilibrium, that they understand each other will be taking, rather than deviate from that equilibrium, because there is opportunity for tit for tat in the next period. Okay, let's say if they know that there is only a number of periods, for instance, a number of Christmas sales, or a number of periods where the game is going to be played, yeah? Or let's say the license is given for 5 years, and how are they going to play it? If they know that the number of games is finite, yeah, is fixed, then it's very likely that they will choose the low price combination. Okay, why? Because they suspect that in the last period, one of them will deviate. It's either firm A deviate or firm B is deviate, because when you deviate, yeah, let's say you undercut, then you get higher profit. So there's incentive to deviate, because you know there's not going to be another game after that period. So in that case, both of them will remain very suspicious of each other, and therefore they think it is safer for them to adopt a low price, yeah, so that no one has the incentive to undercut, because you're already at low price. Okay, now with a sequential game means one company or one firm is able to move first before the competitor, yeah? Either by production, by commitment, by announcement, by advertising. So they show that they are able to deliver something first before the other company. So this is what we call sequential game. If you remember from chapter 12, this is an example Steckenberg, yeah? Model. Now, because it's a sequential game, so you can't use a payoff matrix. It's best to use a decision tree diagram to show what you can do. So let's say in this example, firm 1 can choose crispy or sweet. Yeah, same thing. That this is a serial case again. And if they choose crispy, firm 2 can decide to produce crispy or sweet with this outcome. If firm 1 choose sweet, then firm 2 can again produce either crispy and sweet with these outcomes. Okay, the best outcome is if the market favors a sweet, very variable, a sweet kind of cereal. So firm 1 will definitely choose, or they will book this one first. Yeah, they will produce sweet cereal, and firm 2 will have to decide based on firm 1's decision, which is to produce crispy, and therefore you end up with one Nash equilibrium, yeah, at 2010. So this is another way to show the sequential game, and this can be extended. Yeah, this can be extended because you have